Hey guys, and welcome to another Mr. Fourth Dimension video. This is the Geo project. Last thing we did was we got midpoint and interpolation done, and now I'm thinking we're going to start messing with some circle math, just because it's the next thing that I feel like doing, and because whatever I feel like doing is what we're going to do. So that means we're going to start by needing some pi. I'm just going to plug in a quick constant for pi and get stuff started. Let's see, let's put this up here near the top. We're going to define it as a static or a global constant, real 32 pi equals 3.1415926. I think that's about as much precision as you can get out of a float. I'm not sure. I'll check off screen, see if I can increase that precision anymore, but that's probably plenty. So let's do some basics. So a circle is defined as a point and then a radius. Now, maybe we want a struct that is a circle that contains the point and the radius. I'm not sure if we want that. It's hard to tell. We'll start without that, and if we want to, we can condense these into things that use structs later. So, geo circle area. We'll take a geo point 2D. We'll call this center, and geo or real radius. So this area of this, actually, this doesn't need a center, does it? To get the radius, we just need, or to get the area of a circle, we just need the radius. Should have thought of that. And that's just going to be radius squared times pi, right? That's the area formula for a circle. Let's also do a circumference. Right? Real 32 radius, again, is all we need. No matter where it's positioned, this works out the same, and that's just the radius times 2 times pi. Alright. Now, let me set up some quick test for this. I'll keep all that. We'll do a loop from I equaling 1 to about, let's do, I don't want to do 0 because I'm going to use this to create the radius. The I is going to become the radius, and I don't really care about a radius of 0. That's a boring test to me, so I'm starting with that. But then, let's see, real 32 area equals geo circle area. The radius will be, we'll do divided by 5.f. That way we're going from 1/5 to 5 as our radius is. And same thing with circumference. I might be spelling that wrong. I'll also check that off screen when I'm done here, because I'm not a great speller. That's why I didn't decide to become a YouTube channel about spelling but programming, you know? Also, I don't know that that would be any fun to watch. Not that this is particularly fun to watch, from what I can tell. Let's see, so that's radius, area. We're going to want a little bit more precision for these because they're basically not going to be just zeros there, but I don't want all of the data because I don't really care. Just kind of trying to make sure that the numbers all look roughly correct. It'd be impossible to know for sure, except for at a few points where I know what the radius or circumference and area are supposed to be. But simple stuff like this usually works the first time. So, conference. so long as it builds points unused. So this is where I'm going to use allow local. So allow local is a macro that I have to fix just this warning, because I think this warning is useful. It tells me that I have a local variable that I created that didn't end up getting used, because that normally means that at some point you were using this local variable and then you changed your code in such a way that it didn't come up where you thought you would need it, so you created this local variable but then you didn't use it in the algorithm after all. And this just lets you know, hey, you're wasting a bit of time making this local variable. Let me show you the meta file. Allow local basically says ignore the fact that this thing is not being used, allow it to exist anyway. And the actual syntax for that is just you put this, like, I don't know, cast to void or whatever you want to call it. This doesn't create a machine instruction as far as I know. It just says, like, use this name right here. So the name is technically being used somewhere so that it's not unused. And I don't, like, understand the syntax, so I just make a macro called allow local. That way when I read it, I know why it says that. And when other people read it, they know why it says that. And if you put void there and you don't know this weird syntax, they don't know what it means. Whoops, not the one I wanted to kill. This one, there we go. Let's try it again. Cool. There we go. So as I said, first I want to make sure they're all just increasing, because that's the first check to make. Looks like they are. Yep. And then for the radius of 1, this should be an area of pi and a circumference of 2 pi. Yeah. Cool. Looks like we're good. At a radius of 2, the area and the circumference are the same. That's a fun little thing too. If you do the math, it makes sense. They should both be 4 pi, right? Well, anyway, those are working. So now let's also do arcs, right? An arc is a portion of a circle. So like if I want to do the area of half a circle, or the area of a tenth of a circle, or the circumference, the length of an arc that goes around a circle, right? So I want to be able to find the areas of those. So that's I'll call it. It's not arc area. It's like, I can't remember the name. I'll just call it wedge circle. Wedge area radius of the circle, and then the angle basically, and that's in all of these angles are measured in radians. That way, all you have to do to find out the area is you do what you would normally do to find the area of a whole circle, which is radius times pi, and instead of times, wait, how does that work? Take the area and then it's times the angle divided by 2 times pi, if I'm correct here. And then the pi's cancel out, right? The reason you divide by 2 pi is because if you have the angle of 2 pi, right? If you say I want to know what the wedge area is of a wedge with an angle of 2 pi, well, 2 pi goes all the way around the circle, so that means that this should become a 1, right? If angle is 2 pi, then this whole term here becomes a 1, and then this whole thing is just the area of a circle. If, however, this is, 1 pi, then this should become 1/2, and this becomes half the area of a circle. Now, one thing we could do is we could say, hey, this is a match to my geocircle area, so I'll just do the circle area of a circle times the angle over 2 pi. But if we always try to build off of other functions like that, we would miss out on optimizations like the fact that we don't actually need to do any pi multiplications to make this work, right? So that's the formula for the area of a wedge when the wedge's angle is measured in radians. So I'm gonna mark this radians, angle radians. Similarly, if we want to find the arc length, it's the same exact principle applied to the circumference computation, because the arc length is a portion of the circumference, and so it's just again a ratio between how much of the circle we're going around. So it's radius times 2 times pi divided by the angle, times the angle radians divided by 2 times pi. And here again, we see we can cancel this out with this, and we get the very nice formula that the arc length is just the radius times the angle in radians that we want to measure. I think that's all we wanted to do to get these set up, so let's try them right here. Let's start by just plugging in wedge area there and arc length there, and we'll keep the same radiuses, and we'll just say that we want 2 pi, so that we'll get the same exact result as before, just we'll be computing it using the new functions. Alright, so like 1 is still pi and 2 pi, 2 is still 4 pi on both accounts, right? It's all pretty much the same. That's good. Now what we'll do is we'll fix the radius. We'll fix the radius at 1. Because that's nice and easy. And we'll change the angles here. But these we're not going to call... Oh, that shouldn't have been area and area. Anyway, I screwed that up. This should be... So the first part isn't the radius anymore, it's the angle. The second part isn't, well, yeah, we'll call these area and length still. Now, what we could do is, like, just do something like I divided by 1.f, or, we wouldn't want that, right? We'd do, like, divided by 4.f or something, right? So that we're doing like 1/4, 1/2 to 3/4, 1, but integer amounts of radians aren't very useful. Because I mean, radians all the way around the circle is 2 pi. So we kind of want this to end at 2 pi, if that makes sense. So what we want is like 2 times pi times I divided by 25.f, because that'll make this into a 1 when the I reaches 25, and so on the last step it'll be a full circle, and up until then it'll be stepping up by 25ths. Except I don't know if we want 25ths. I want something that I can verify that I know is doing something useful. I think 12ths would be smarter in this case. Times I divided by 12.f. And of course, what we would really like to do actually here is go angle equals like this, and pull this out into an angle variable. That way those computations aren't duplicated everywhere. And we can change them in one line if we need to next time we run this, if we run it again. So now the angle is stepping up and ending at about 2 pi. 1/4, yeah. And then, and halfway through it's at about 141. See, these are rounding up that third decimal, that's why it doesn't quite look like pi, but that's halfway through it's at pi, and at the end it's at 2 pi. And these, the area should end at pi, like before, and it's increasing all the way, it looks like, and the length should end at 2 pi, like before, which it appears to be doing. So I'm going to conclude that arc length and wedge area, I think it's sector, but I want to look that up. So I'm going to fix, things I'm going to fix off screen are possibly the spelling of circumference, the technical term for this area function, and that'll be it. But anyway, we got done what I was hoping we'd get done, which is cool. I hope you've enjoyed it. See you guys next time.